This is a little hard to see at the top of this page, but a stretch or a shrink is going to make the V either look wider or narrower, okay? And on this side, when we've got y equals 2 times the absolute value of x, and when we have y equals absolute value of 2x, when that number is more than 1, then what's going to happen is it's going to look narrower than the original. So this one that I'm highlighting now, this is this one, okay? And then this one would look like that compared to the parent graph. So you notice both of them are going to look narrow compared to the parent graph. That's not a technical term, and that's a little bit of an oversimplification because one of these is going to be a horizontal shrink and the other one's a vertical stretch, and it does matter which is which, okay? But it is worthwhile to know that if you have a number more than 1, the V is going to get narrower. If you have a number less than 1, then it's going to get wider. So this is what that one would look like, and this is going to look like that. So they both get wider. They actually look the same, but the way they got like that is different. One of them is a horizontal stretch, the other is a vertical shrink. So these ones are going to look wide compared to the parent graph, okay? All right, so there's a lot to keep track of with these stretches and compressions. It works in the same way it does with linear functions. So the previous video, I've got a chart that's very similar to this. But yeah, let's look at this again, okay? So yeah, when we're multiplying by a number, like we are in these, that's going to change the width of the V, okay? But that can happen in 4 different ways. So you can have a horizontal stretch or shrink, and you could have a vertical stretch or shrink, okay? So when the A value in these bottom left corners, that's going to be what is in the equation, either a 2. So my A value here is 1/2. Here the A value is 2, and so forth. Okay. What is going to make it a horizontal change as opposed to a vertical is the placement of the A value. So we're multiplying the input by a number on both of these, and that's what makes it horizontal. Where here we're multiplying the output, the numbers on the outside of it's 2 times f of x and 1/2 times f of x, right? As opposed to these where we're multiplying the inputs by the number, okay? All right, so it's when we're looking at this one, this top left one, since it's a horizontal change, that means it's a horizontal stretch. Well, that means that these points are going to move horizontally, okay? And they're going to be stretching, so they're going to stretch. When we're doing a horizontal change, those points are going to move away from the y-axis, okay? And down below, with our shrink, they'll move towards the y-axis. So I'm just highlighting what those are moving to or away from. All right, so with our stretch, these points are all going to move out. Okay, and now since the factor is 2, which by the way is the reciprocal of 1/2, that means I'm going to double the horizontal distance. So I can see this first set of points is 2 units away from the y-axis, so I want to double that. So this new point D, I'm going to label that D prime with a little tick there, would be there, right? Now it's 4 units away from the y-axis as opposed to 2. Same thing's going to happen over here with the A prime. And those bottom points are just 1 unit away from the y-axis, so I double that. And here would be C prime, and then B prime would be out here. Okay, the ticks were a little, the graph printed out a little light, so I'm just going to put in the ticks on the axes. Okay, but then when we draw this in, here's the graph of of f of 1/2 of x, okay? So when we're going in, my factor here is 1/2, so that's what you'd be multiplying those horizontal distances by. So it'd be multiplying the x values because that controls the horizontal distance. So I'm going to take, these are going to be half the distance that, my new points are going to be half the distance, so that would be my new point C. So now those are going to be both half a unit away from the y-axis. Okay, and the top points are right now 2 units away, so I want to take half of that and make them 1 unit away. I won't label those points, but that's what they would look like. And so we're going to get something that looks like that. Okay, so those points are going to move in towards that axis. Okay, all right, let's look at the vertical ones. So on the vertical ones, that means my points are going to move either up or down, which means they're going to be moving towards the x-axis or away from the x-axis. So I'm just highlighting the axis that they're moving in relation to. Okay, so a vertical stretch, so that means these are going to move up and away. So my factor here is going to be 2. That means I'm going to double the height of these points. Okay, so I'm looking at this first point is 1 unit above the y-axis. So I'm going to double that, so now it's 2 units above the y-axis. Okay, and same thing here. And these points are 2 units above, so I double that to make the new ones 4 units above. Okay, and then I can draw in my new V. All right, these ones I'm going to take half of the height. It's really multiplying the y coordinates by 1/2, and that's gonna give me a V that's wider because all these points are going to move down towards the floor, towards the x-axis. So I'm going to take half of that height, I'm going to take half of this height, and the same thing on the other side. Okay, so yeah, a lot to process, but at least we got it all in one chart here. And you know, I'm using 2 1/2, but if we did 3, then my factor would be 3, and I would triple the height of those points or whatever, right? Okay. All right, let's try some examples on the next page. Okay, so we've got, let's look at the equation side of things first. Not going to do any graphing on this page. So vertical changes is when we're multiplying the output, so this a value, we're going to be multiplying the whole function, we're all of f of x by something. Where with the horizontal changes, we're just multiplying the input, right? Okay, and then you can tell if it's a stretch or shrink based on the value of a. So with our vertical changes, if a is going to be between 0 and 1, so a number less than 1, then we've got a shrink, and if it's a number more than 1, we've got a stretch. Okay, and that kind of flips around on the other side. With the horizontal one, the shrinks are going to be when a is greater than 1, and the stretches are when it's less than 1. So it's a little confusing. Also, notice the factor is the same as a with the vertical ones, but it's the reciprocal when we're doing the horizontal ones. Okay, so I've got this split into 2 columns. So let's just start with the vertical changes. So I'm going to write a function g. So I'm going to call my new function g of x. And it says it's going to be a vertical stretch of f of x by a factor of 5. So the factor is just the a value. So that means up here, this a value is going to be 5. So I'm going to take 5 times f of x. Okay. Now what I'm going to do, so this is going to be my new function g. I'm going to have to multiply f of x by 5. Well, I'm going to substitute in where it says f of x. Okay, because right above I can see f of x is equivalent to all of this. Okay, so I'm going to substitute in, and it's really important to use parentheses when you do this. So this is going to be absolute value of x minus 2 plus 3. Right, I just substituted that in where the f of x was. I need the parentheses because I'm going to have to distribute this 5. And there's a lot of mistakes that get made with the distributing. Some people just forget to distribute altogether and just leave it like this without the parentheses. But what you want to do is distribute it like this. Okay? So that gives me 5 times the absolute value of x minus 2 plus 15. Okay? Now, the other mistake that gets made, people will distribute into the absolute value, but you can't do that. It doesn't work like regular parentheses. So there's nothing else we can do with this. So that would be the same as doing a vertical stretch by a factor of 5 on f of x. Okay? All right, so when we're doing a vertical shrink here, we're going to use the same kind of strategy. So this is going to be my a value, so I'm going to take 1/2 times f of x. And again, just like the last problem, now I'm going to substitute in for f of x. I'm going to substitute in all of this, and I'm going to use parentheses when I do that to help remind me that I'm going to need to distribute. Okay. So here, let's distribute the 1/2. One of them is going to go there, but then also we're going to multiply the -5 by 1/2. Okay, and then I'm thinking 1/2 times -5, well, it'll come out negative because a positive times a negative. And you can think of this as 5/1. And then 1/2 times 5/1 would be 5/2. Or you could say -2.5, that would work too. Okay, and then there's nothing else that we can do there. Okay. All right, let's try the horizontal one. So now our a value is in the input. Okay. All right, this says write g of x for a horizontal stretch by a factor of 3. Now this is a little tricky here. This is the a value, but then sorry, that's not my a value. That's my factor. Sorry, factor equals 3. But the a value is the going to be the reciprocal. So that means a is going to equal 1/3 actually. Okay, so that's the number I'm going to use for a up there. Okay, so looking at this, I've got f of 1/3 times x. Okay, I often see people just do f of 3 of x, and I get that because it's confusing because that's what we would have done if it was a vertical change. But with the horizontal ones, you have to use the reciprocal. So you flip this fraction upside down. It's not a fraction, but you could write it as 3/1, and then the reciprocal would be 1/3. Okay, and now what I'm going to do with this one is I'm going to input this into function f. So this is f of x. If I want f of 1/3 x, well, then I've just got to replace the input with 1/3 x. So I'm going to replace that x with 1/3 x. All right. So that means g of x, I'm going to take 1/3 x, still got the +3 and the -7 out there, an absolute value. And there's nothing else that I can do. I can't simplify any further than that. Really, so really you're just replacing the x with a 1/3 x. All right. And on this next one, if my factor is 3/5, well, that means I'm going to take the reciprocal of that 5/3. Okay. So g of x then is going to equal f of 3/5 times x, or just 3/5 x. Okay. And here then I'm going to input this in for x into function f. Okay. So I'm replacing the x with 3/5 x. And then there's nothing else I can do to simplify that. Okay. All right, and then let's do some graphing that involves stretches and shrinks. So this is a little challenging, especially when it's new to you, when you haven't had experience with it. If you have that chart in front of you from the notes, that's great, but of course we're not always going to have that in front of us. So this is what my method for doing this. First thing I would do is find and plot the vertex. Okay, so I'll go through these steps as I'm talking about the different steps here. So finding the vertex here, I'm going to take, some people say, oh, it's going to be -3, -2 because they just changed the sign of this, but that's not quite correct. You have to take everything that's inside the absolute value and set it equal to 0, okay? Then I'm going to solve this equation, and that's going to give me my x value. So the 1/2 is going to affect the x value here, okay? So I want to get x by itself. I'll start by subtracting 3 from both sides. Okay, and then I still want to get x by itself. So what I'm going to do here is multiply both sides by 2, because 1/2 times 2 is just 1, and then I'd end up with just x on the left side. Now I've got x equals -6, because those cancel each other, right? Okay, so that's my x coordinate. My y coordinate is whatever is added or subtracted to the end. If there's nothing added or subtracted to the end, then your y coordinate would be 0, but here it's -2. So my vertex is going to be -6, -2, okay? I'm going to go ahead and plot that on the graph. -6, -2 is right here, okay? Once you get the vertex in place, there's my vertex, I'll put a little v for it. It's not going to move with any stretches or reflections or shrinks or anything like that, okay? All right, so step 1 is complete. Step 2, I'm going to lightly graph the what I call the ghost. It's just something I made up. So what that is, the ghost, is it's my parent graph, but opening from this vertex, okay? So the ghost, that's without stretches or shrinks. But I would include any reflections. So the only thing I'm really looking for on the reflections is if it's opening downwards. This one's not opening downwards because I don't have a negative in front of the absolute value. Okay, so it's going to open upwards. So my ghost is just I'm going to kind of just ignore the 1/2. That's going to cause a stretch or shrink. But if that wasn't there, then I'd just be going up 1 to the right one, up 1 to the right one from the vertex, and I'll go up 1 to the left one, up 1 to the left one. So that's my ghost, okay? So I often just plot the points. You could do little dashed lines or draw it lightly with pencil or something like that. We're not finished with this yet, but it helps to have these points in place because the vertex stays put, and we're going to do the stretch or shrink on the other points. Okay, so these points are going to move with a stretch or a shrink. Okay. So the hardest part of this is to move those and get them in the right spot. So my last step here is going to be graph the 5 critical points. And by the critical points, I mean you'll need the vertex for sure. And then I like my students to do 2 more sets of points. Sometimes you might not have room for that on the provided graph and just fit as many as you can. But so here, if I get these moved correctly, I'll have my 5 critical points, okay? But now I'm seeing that I do have this 1/2 I have to deal with, okay? So I'm not going to use that chart. Here's how I think of it. I think, okay, if this is a number more than 1, it makes it narrower. If it's less than 1, it's going to make it wider. So I know that my graph is my v is going to end up looking wider than this original function, okay? Than my ghost, I mean, all right? Now, that's not a technical term. You could just kind of draw in a wider one, but you'd want to get it correct. You want to move those points in the correct way because there's 2 different ways to get a wider v. All right, so then I'm thinking, well, is this a horizontal change or a vertical change? And that depends on the placement. So you see how the 1/2 is multiplying the x directly. Well, I think of the x-axis as the horizontal axis, right? So since that 1/2 is touching the x, that means I know I've got a horizontal change. Okay, and then the trickiest part of this that I spent a lot of time trying to explain, I need to figure out now if it's a stretch or shrink, and what I'm going to do is put these 2 things together. So my vertex is staying put. With a horizontal movement, that means these points can only move left or right, okay? So I'm thinking, well, which way would give me a wider v? If I move them in, my v is going to look narrower, right? So I'm going to have to move them out. And then I'm looking at this and thinking, okay, since this is 1/2, I'm going to actually do my a value is going to be 2. So I'm going to double the width of this. And even if you didn't remember that it's the reciprocal, we know it's going to be wider, and since it's a 1/2, that means it's getting twice as wide. If it was 1/3, it'd get 3 times as wide. Okay, so looking at those 2 bottom points, they're 1 unit away from the middle of the v, so I want to double that and put them right here and here. So those points are moving out. Okay, and then so here's the center of my V, right? I'm just kind of lightly doing this just for visualization purposes. So this is 2 units horizontally from the middle of the V, so I want to double that and make it 4 units. Okay, and the same thing on the other side. And now we've got our V. Oh, in the notes up here, I sometimes use the word compressing. Some of the books do that instead of shrink, but that's the same thing as a shrink. Compress just means like press together, right? Like that. Okay. All right, so let's try another. It takes a lot of explaining for me, but once you get the hang of it, these problems aren't actually that long. So first step here, I would look for the vertex. Okay, I solved that by subtracting 2 from both sides, and then this is going to be my y-coordinate. So my vertex is going to be -2, -1. Okay, so let's go ahead and plot that. -2, -1 just fits on the provided graph there. I'll just put a little v to remind myself not to move that with any stretch or compression. Okay, then I'm going to do the ghost. So I know this is going to open upwards because I don't have a negative in front of the absolute value. So my ghost, I'm just going to go up 1 to the right one, up 1 to the right one, up 1 to the left one, up 1 to the left one. Okay, and then the hardest part is I have to deal with this 3. So I'm thinking, okay, does that make it wider or narrower? So since it's a number more than 1, you got to just remember that when you have a number more than 1, it makes it narrow. If it's a number less than 1, like the previous problem, then it makes it wider. Okay. Now I'm looking at the placement of the 3. So I'm thinking, is it touching the x directly? It's not. So if it were inside touching the x, it'd be a horizontal change. Since it's not, this is going to be a vertical change. Okay. And then my last part is thinking, okay, these points are going to move vertically. That means they're going to move only up or down. And I'm kind of just visualizing, well, if I need a narrow parabola, if I move these down, these points down, my V would get kind of smushed like this, and it's going to look wider. If I move them up, then my V would kind of stretch and look narrower, right? So if I move these up, I will end up with a narrower V. That's what I want. So these are going to stretch then away from the vertex. So this is a vertical stretch. Okay, and the factor is going to be 3. So this means it's going to get 3 times the height of these points is going to multiply by 3. Okay, so I'm looking at the height of that point and the height of this point. Same thing over here and here. So this is 1 unit above the vertex. So let's triple that. So I don't want to go 3 units up from the point. I want to go 3 units up from the vertex. So 1, 2, 3. So it's another 2 units from where it is, but it's a height of 3 units. This one's 2 units above the vertex. I want to triple that. So that would be 2 times 3 would be 6, right? So from down here, 1, 2, 3, 4, 5, 6. Just fits on the provided graph. And then the same thing happens on the other side. And now I've got my V. Okay, so yeah, there's a lot to digest on these problems. It takes some practice. It's one of the more difficult topics in the book. All right, that's it for this video, and I'll see you next time.